Alright, hello everybody, welcome back. It's a new day, yeah, this is part 2 of my robot bearing hat series. So since yesterday, I did a little bit more thinking about this feature and what I want it to be. And so I realized I don't actually want to create the bearing holes in this feature. I think what I can do instead is have the user select an edge adjacent to a bearing hole, and then we add the bearing hat on top of that. That does a couple things. One, when they choose the edge, then we get like the merge scope, because we know like what part that bearing edge is associated with for free. And it also tells us like the direction and everything. And two, it pushes the problem of having to create the bearing hole and like figure out like what fit the user wants and whatnot, because they have various tolerances for manufacturing and things, and it pushes that off. Because they can just sketch it however they want or use the whole tool or whatever preferred dimension they have. It's not my problem. And then I just come in after and add the bearing hat onto their existing hole. And then so that's the first thing. So that's the biggest change. And the other thing I think I want to do is I actually think I want to limit this to one bearing hat at a time. This comes up in FeatureScript a fair amount, right? You have this idea of like, how much do you want to do in a single feature? And generally my current school of thought that I'm subscribing to more and more is I think it's better to limit to one anyway, because most of the time when people use features, they're only doing it once regardless, right? Like, when's the last time you used extrude to extrude like two different parts at once, right? Or, you use revolve and like revolve two different things at once, like two different like parts. And the answer is it doesn't really come up that often, right? And the benefit of limiting to a single one is your selection becomes tied to the feature itself rather than like whatever you've clicked on, right? So if you have a feature that creates a single hat, right? And so you add that to a hole and then, your model changes, it updates, you delete that hole and recreate it somewhere else because you're updating your geometry and you like redraw the circle in the sketch or something, right? If you are using if your feature supports multiple, when that hole is deleted, right, that reference is going to be gone and so your assembly mate's going to break, right, and like all of that's going to be cooked. But if your feature only creates a single thing, right, then when you edit your feature to use that new hole, right, because it's the only thing that feature creates, it's a little bit more robust and there's a better chance that Onshape is actually able to track that. And so then like your assembly mate might actually be okay. And so you wouldn't even have to like update your assembly. You just, change it over to your parts studio. It's not a problem. Also, I think if we ever start actually modeling the hat and doing some of the fancy things I want, this is probably a better reason to be honest than like some of the robustness things. You can really only do one of those at a time because if you have to like specify like the directions you want like the holes to be in, if you are doing like custom bearing hat things, then having, you really only want to do one of those at a time because, otherwise you're trying to specify, you have to do like an array parameter or something, it gets really goofy really fast. And so I think it makes sense to limit it. So we're going to be making those changes today. So the first thing then is we don't actually need, so if we get into it, so I think in terms of selection style, external thread is probably a reasonable basis actually. Cylinder edges, yeah, so this is actually very similar. And I might actually steal that, to be honest. Let's go find that. Oops, wrong search location. External thread. Okay, here's the feature, and here's their selection. So I'll go ahead and steal this. So again, I'm just doing the same thing I did yesterday. Although this time going off of what I was just talking about, right, I don't think it has to be unconfigurable, right? And they have a bunch of things on here. Edge to poly depth two-sided, no, modifiable entity, yes. Okay, this all seems reasonable to me, right? So it's a circle, it's an arc. Oh, they also allow arcs. I don't want arcs on here, I think. because it shouldn't. I want a full bearing hole, and then I'm going to limit this to 1. Using this, right? If you're wondering like what these parameters are, right? So if you search like FeatureScript documentation, you should end up on this page, and then the first link, and there's a couple different things. So there's tutorials, which you can look through, and then there's the standard library source, which is this document std. That's the source code. Usually, that's it's pretty hard to parse if you're not pretty familiar with code in general. But it can be useful for stealing parameters like I've been doing. Otherwise, and then you also have the standard library documentation. So this is the documentation for like all of the public functions and like their parameters and return values and whatnot, which is pretty handy. There's also this handy. There's a bunch of other stuff in here for like syntax. This is pretty verbose. So if you're not like familiar with another programming language, because it focuses a lot on like the difference between FeatureScript and other languages. If you're not familiar with other languages, then it's not going to make a ton of sense to you probably. But this feature UI is pretty helpful. It goes through all the various options and the documentation for them. So here, if we scroll down to queries, right, we can see this max number of picks is an option, and I have an example here where you can limit it. So that's what I'm doing here. And the rest of these filters look good. Edge topology have two-sided. That guarantees, it'll have two sides to it. So it's like, like if you think about like a hole or a circular edge sitting on a whole face, it should have two sides. That makes sense. Not a construction object, so no like holes in like a plane or something. Can you do that? I don't think so. But like no like sketches and things. Has to be modifiable, so no, no in-context assembly ghosts. A lot of mesh geometry, no meshes, and no sheet metal. That's fine. Okay. So we'll do that, and then I will name this place hat, right? And this will be my bearing edge, right? Okay, and the nice thing is we don't actually need a scope here because we can get that from the query directly. And then we'll have our fit. Okay, so we'll get rid of this part and this part, right? And we'll verify our new parameter, right? So same thing. It's our bearing edge now, right? And we're going to say select bearing edge to place to use. Okay, and so now the first thing I'm going to want is I'm going to want to get that owner part. So I'm going to want to figure out what my scope is. So in this case, I know. So the best way to figure out, anytime you have like queries and you want to work with them, the best thing to do, I think, is to go to the standard library documentation and scroll down to queries, which is here, right? And so these are all the query functions. So there's a bunch of filters in here, right? The geometry type, cap type. Some of these can be pretty helpful actually, but once you get down to the actual query functions, right? There's all sorts of useful things in here. So like queue everything, you can query for everything. Solid bodies, those are like the generic for querying for everything, right? Queue as attributes, so you can like query by attributes and things. If we scroll down a little bit further, queue created by, or bread and butter, of course. So here we get into some of the geometrical ones, right? So for example, I can query for, if I'm using OP hole, I can query for the results of that. Which are not. Queue union, queue intersection, these are your basic set operations for queries, so you can like compose them. And here, like queue owned by body, queue owner body, right? So you have your basic relationships. And so here, this is actually what we're going to want to use, right? We can use queue owner body here on our edge because our bearing edge will actually have an owner. And then we're going to want to filter by solid bodies. So we'll do queue body type and body type.solid. And do I need to do an entity type filter? Let me check. Could do body. No, but if it's a solid, then it's implied that it's a body. So we'll I'll assume that is right. I'll check it with a debug as well, so I can just verify. And then I'm going to do some error handling. So if is query empty context scope, right, then I'm going to throw region error, and I'm going to say part, right? So that's my standard error handling, right? And then there are other useful region error overloads, right? And so the main ones are you can have queries and you can have parameters, right? So I'll demonstrate that, right? So the way you highlight parameters is you put the name of the parameter in string literal in an array. So here I'll highlight bearing edge because that's the problem here, right? Is they've selected a bad bearing edge. And then I'm also going to actually highlight that edge as well, right? So here I'm taking advantage of this overload that takes faulty parameters and entities, right? So I'm passing in the bearing edge to highlight it in red in the graphics window. And I also passing in the parameter to highlight that parameter in red as well. And so with only a single query parameter, it's not the most obvious, right? But I'll just add another one in here, for example, just so when we look at it in the model, right? And then I'll comment out this code, right? So now I need a bearing hole, so we'll just make one real quick. Okay, yep. So now when I do my robot bearing hat feature, right, it asks me to select an edge to place my hat, right? And we can see here we are getting that part. I think it's going to be pretty hard to find one that doesn't have... Oh, here's an easy way, actually. If I just have a cylinder, right? And I extrude my entire sketch, please. Thank you. Right. So here's an example of a cylinder that I can select, right? So I'll probably want to do some querying to handle this case as well. So I'm not trying to, because that's kind of goofy, of course. But you get the idea. Actually, I do wonder if there is an easy way to detect those. But yeah, so this works, right? We can see our debug was highlighting our entities correctly. And I'm not going to worry. I guess you'll just have to take my word for it on the error handling. Because this is a pretty niche error to find anyway, because we have so many filters on here. Between circle, no sketches, and edge topology, no construction. I think that should handle most of our cases. But it's here if anyone ever goes crazy or something. Okay, so we like that. So now we want to know if it's a whole face. And so when we were scrolling through here earlier, right, we did notice there were some functions for, you can check if it's like an OP hole. Of course, if they're like extruding a circle, you're probably not going to have those parameters. If I keep scrolling here, Q adjacent. So you could guarantee it's adjacent to a cylinder. That still wouldn't handle our big case though. Connected faces, loop edges, loop bounded faces. Could try to use that to get the whole face. Q whole faces, interesting. Turn all faces of the whole. Let's give that a shot, actually. Oh, that requires a face inside the hole, which we don't necessarily have. So that probably won't help. Although you could use like Q adjacent, but then you have like two faces you have to figure out. Yeah, and like one of them, you could require one of them to be a cylinder, but that still doesn't solve your problem. So you have a couple options. You could probably do like, if you query for like the adjacent faces, you have two adjacent faces, and then you guarantee one is a cylinder, and then that cylinder, you assume that's the whole face, and then you can use you could use Q whole faces and verify that the other is like, Well, that would, yeah, I don't know, maybe not. Well, then you could try using like Q edge face or edge bounded faces or like Q loop bounded faces, and like verify that they return each other. So you do have like a proper setup there. I don't actually know if that filters out the cylinder, but yeah, and then none of these other ones seemed particularly helpful. But yeah, so otherwise then you get into the evaluate functions, right? So these are for turning queries for things into geometrical representations, right? So these will all return usually math representations, right? So here, for example, mass properties, right? That's going to be some physical numbers representing the actual, mass centroid, etc. For geometry. Evaluate area, that's going to return like an actual area of something, of like a face or something, right? So it's going to like physically measure it. And so here, right, evaluate curve definition, I think, is going to be pretty handy. So we can get an actual circle representation for a curve. So we could do that. Although I do want... I guess there's not really an easy way to detect if it's an actual hole or not. Let me see if there's another one. Evaluate length, sketch plane, planar edge. I could do this and try to get a cylinder. Points deviation. Okay. None of those are particularly helpful. Let me go back again. I wonder if there are shenanigans where I tried doing what I was describing with the queries. I also wonder if it just doesn't matter. Is there an easy way to query for the adjacent? Well, I guess I can query for the adjacent, and then one of them should be a cylinder. And then the other one you would want to have returned by... but that doesn't filter out the cylinder case. I don't know. Maybe I guess I'm not going to worry about it. If people are being goofy and selecting cylinders, like, they deserve what they get, frankly. So I'm not going to worry about that. Yeah, and it'll probably fall out of, like, the extrude will fail, and then, we'll do error handling there, so they know what's happening. Okay. Cool. So let's keep cracking along here. So we do probably want our hole, right? So evaluate does seem like what we want here. So I think what we can do is we can run evaluate curve definition and go ahead and grab our circle, right? So let's do that. Definition edge, definition dot bearing edge, right? All right, I'm just going to inline this. So it's a little more concise for me. And then I'm going to check if circle, let's see, what does this return? Recruiters now usually return a map with unspecified contents. I guess it will throw if it is invalid. And then if we look at the return value, it returns a circle, presumably, and we can type check it. So if circle is circle, that should run the type check function, yeah. Circle, bearing edge, definition dot bearing edge. And I'll throw this in a try loop as well. Just in case our evaluate curve definition does something funny. Right. Do I care? Okay, I'm not going to worry about it, I guess. Yeah. is this even right? Yeah, so here's an example. They run it, and we can see there's no try catch loop. This is just a random example. I just typed is circle and I found one immediately. That was actually pretty fast. So we can see here they're using valid curve definitions, right? And they're checking, if it circles. So they are doing the exact same thing we're doing. So I feel good about that. So that's just an example of how you can use a standard library, even if you're not a great programmer. Like there's a bunch of goofy code in here, of course. And who knows what this is. This is a huge function, right? But if you look at this, I can see valid curve definition, I can see there's no try catch loop, right? So I can intuit okay, I probably don't need to worry so much about try catch on my valid curve definition, and I can see is circle is a valid way to check if the result is a circle. So yeah, so that's good. So now we should have a circle, right? And so if we debug this, right, we can check. Right, so I click my bearing and we scroll down and we are in fact seeing a circle, right? And so one thing that's important about this, right, circle.z-axis, oh, it has a chord system, okay, chord system.z-axis, right? So if we look at the documentation for a circle, right, we see it's a map, right? It has two key value pairs, one is a chord system and one is a radius. Right, so we know how big it is, and we know, where it is, and then we know the circle lies in the xy plane of this coordinate system, and the origin of its parameterization is the x-axis. Cool. So the thing I'm curious about is where is the z-axis on here, right? So a chord system, of course, is, if you look at this is just another map, right? And it has an origin, an x-axis, and a z-axis, right? And we can convert between a chord system and a plane pretty easily. So I'm just going to go ahead and print that out and see which way it's pointing, right? So you can see here, because it's just a vector, it's just on the origin, because it doesn't actually have a representation. It's just a direction, right? It doesn't actually, or vectors are unitless, so it's not actually from that point. You need a line or an axis to have that. But we can see, so here, this circle, it's facing that way. And if we flip this around, right, so it's still facing the same way. So that's good to know. And here it's like that, right? And there it's like that. So it's arbitrary for the direction of a hole. It looks like probably the direction of the extrude, or opposite, I guess. Okay, so that's good to know, right? Because that means we're not quite out of the woods yet, because we do need to know which direction the hole is in, right? So we can extrude the right way. We don't necessarily have to figure that out. We could just extrude both ways. But there are versions of this where, if you were to actually model the hat, you do want to know that direction, and so being able to figure it out would be helpful. Although I do wonder, I don't think this is something that you're going to be able to figure out reliably, right? You could do the Q adjacent thing, get the whole face, get the planar face, or the bounding face, and then try to run a valid plane on that to get the face, and figure out the direction from that, right? But the bearing hole isn't guaranteed to lie on a planar face, right? So evaluate plane could do something goofy. And so generally when you get into heuristics territory, right, it's usually better not to try implementing those in the feature body. And if you think you can come up with a reasonably good approximation that should work most of the time, maybe that's something better for editing logic, right? Where when a bearing hole is first selected, you take a best guess using some code to try and set the direction automatically. But yeah, so we know from the standard library, this is a pretty common thing, right? For example, hole feature, right? Anytime you're adding a hole, it does its best to set the direction for you, right? But you can always change it yourself. So this sort of pattern of being able to change the direction, I think is probably the way to go here. And actually, I think, so if we think about the rotation feature, actually not quite, I don't love that. If we think about positioning a mate connector, right? So, if I wanted to position a mate connector over this hole, right? Yeah, so it always knows the outer direction, which is interesting, actually. But are there cases where that could be wrong? I guess so, right? Well, how does that work? Actually, now I'm curious. Because I know for make connectors and assemblies, if you grab the whole, right, or the whole face, and you have the start, middle, and end, right, this is always one direction, right? We actually were seeing that earlier with the edge. But this edge here, right, on the face is always facing outwards. I guess it's because it's implicitly from the outer face and not the whole face. But how does that work then? That's interesting. I guess one thing at a time, right? So one thing I do like about this is you have your flip and you have your reorient, right? So you can turn it 90 and rotate it around. So this UI right here I actually do like a lot. So I'm probably going to steal that. So let's go open that up. Make connector. Yep. So this is the make connector feature. And I believe this is actually also used in assemblies, right? So there's the make connector feature as well. But you also get a variant of this when you click like this button, you select a make connector, right? And when you click this to edit, this is also the make connector feature brought in line. And same thing in the assembly. Although the assembly doesn't quite run FeatureScript, so I'm not actually 100% sure how that works. But like the parameter names and things are all the same underneath the hood. So yeah. Anyway. Yep, so if we look at the code, right, we see origin type, origin entity, right? There's some hidden parameters in here for inference type. That might be the secret to how they're able to get the direction, actually. Part origin point centroid. Respect to an entity. Face normal. Along the normal of the plane which the edge lies on, or the center of a sphere with the world coordinate system. Aha, so this is probably how they're doing it, right? Z-axis along the normal of the plane which the edge lies on, right? So that's the face version, right? Anyway, that's beyond the scope of what we're doing right now. But that is like an inference type, so I think that is something that's kind of like implied or like calculated via editing logic rather than something they necessarily, is 100% reliable. G inference type. Now I'm curious. We are falling down a rabbit hole, which I accept. It does take an inference type. Where is this used though? Oh, is it just past OP make connector? Yeah. Oh, no. OP make connector. Transform result if necessary. All parts, lots of query logic, lots of thinking, lots of finding owner bodies. That returns owner bodies. Let's see, this function ends here. It might just be like an internal thing. I'm actually not sure. There might be some internal wrapper shenanigans going on with this, or maybe I'm just missing it. I'm surprised it's not... Oh, no, here. Yeah, okay, so it's passed here to evaluate make connector chord system, which is an internal function. This is a little hidden, right? That's interesting. So this evaluates the make connector coordinate system for something. And this is robust enough that they're able to use it at runtime. Interesting. So maybe this is a mystery function that would be helpful for like editing logic, because you could pass in the inference like center, assume that's an edge, let this do its thing, and then try to set the z-axis based off of that. That would be cool. But I don't think that's robust enough to use at runtime. Although it could be, honestly. I'll play with that later, probably. Anyway, but yeah. We're getting massively sidetracked, as per usual. The part I want is here. Wait, is that what I want? I think I want these guys? Wait, hold on. Sorry, getting sidetracked again. Make connector. That's there. Okay. Make connector. I want flip primary axis, reorient secondary axis. Flip. Okay, yep. So these guys. So we'll do that. So just grab those two guys here and slap them down here probably, right? And then we need a make connector axis type. So that I think, let's see, make connector axis type. Aha, yep. So here I can steal this import. So if I copy paste this, and then I know what, Windows V? Nope, wrong Windows key. Windows V, yep. Didn't copy. Oh, that's so sad. I need, I swear, what is it copying? Okay. I copy paste, nope, okay, it didn't work. Make connector axis type gen. Type.gen.fs, right? And because I need the enum, I'm gonna have to export it because enums have to be exported. But that should give me that. And we can see it's no longer throwing the error, so it's happy, which we like. So cool, we're happy with that. And then I'll go back to make connector, because there's one other piece of UI I like. I like this rotation angle, I think. Although, yeah, and I do also want to have a rotation reference, but one thing at a time. Okay, so I'll steal that as well. And I'll probably steal, I don't know, let's see what that looks like for now. Right, I don't need this. Okay, so we have our flip and we have our reorient secondary axis, right? And then we can also specify rotation angle, which is good. And it defaults to 0, which we like as well, right? Cool, so we're happy with that. I guess rotation should probably be like revolve, kind of. Revolve angle, maybe like transform. Angle, and then you have a flip on it. That makes sense. Okay, so I actually probably want to do something like this. And what did that say? Rotation angle? That seems reasonable. Actually, probably just angle is fine, I think. So let's go steal, what was that from? Transform? Let's go steal that. Right. And you could, of course, make your own UI. You don't have to always, I think it's actually transform copy is the actual feature. Transform is like the geometrical transforms you use in Onshape, like the math, you know, like a 4x4 matrix of numbers that defines like, you know, an arbitrary transform in like 3D coordinate space. So transform copy is the actual feature because it transforms and copies, and just because transform was obviously taken. Because I think, you know, for programmers, the math version is a little bit more important than the feature version. Obviously to users, you know, you don't care about the math, but us programmers, it's near and dear to our hearts. So, okay. Yeah, so humdy-dumdy-dum, here's the UI, right? So we see the different modes, make connector, rotation, here we go. So here's the angle, and here's the opposite direction. This is actually just the bog standard opposite direction Boolean they use everywhere. So I'll grab that. Interesting. I guess because it's rotation. Yeah, so the fun fact is angle 360 bounds, the default is 0, or is 30 degrees on that guy, which you just know from experience. But if you mouse over the documentation, you can also see it. Oh, it's not going to complete. Yeah, so like if you do like angle 360 bounds, right, so we see it defaults to 0, which is not, or it defaults to 30, which is not what we want. We want to be very careful. And the reason why that is, it sounds a little counterintuitive, but that's for like features like revolve, where a 0-degree revolve doesn't make sense. It's actually not allowed. Oh, it actually is allowed. That's funny. But it doesn't make, you know, as much sense as it might otherwise. So instead, there's a 0 default specifically. But yeah, so that's our angle, and I'm going to name it, I'll probably name it angle as well. Rotation, I think rotation makes sense. Okay, and that's flip primary, so it doesn't conflict with opposite direction, which is good. So now our UI looks like this. Cool. And then, do I want an angle reference? Yes. So I'm also going to add one more thing. I'm going to add an angle reference query, right? And so this is not really something you see in Onshape, so I'm going to have to home grow it. And so basically the idea is you can select like an angle reference to point towards, and then you can also like set the angle on top of that. So very fancy, but I think that's helpful. And there's certain edge cases where you want to like align with like something somewhat arbitrarily, and so being able to do that is helpful. And then for this, so I know from experience there's actually some query utils. So there's an query enum. I'm forgetting what it's called. Extract direction, I know, is the version. Yeah, so there's this enum here, query filter compound, right? So these just compose some helpful ones. And here I think the one that's helpful to us most is this allows direction. Although, let's see, like the line is good, that makes sense. Plane also kind of makes sense, because you can use like the plane normal. Circle and arc and cylinder, those do define directions, but it's a little finicky. I can't imagine anybody trying to use that with this. And I also like allows vertex here, because you can click a point, and if you project that onto like the plane, or if it's already on the plane, then like that you can just orient towards that. That kind of makes sense. So maybe what I'll do is I'll probably do geometry type.line and plane. Plane just seems, I think just line and allows vertex makes sense. So let's do that. Allows vertex or geometry type.line. Okay. Cool, so we'll do that. And then I'm wondering if we need a rotation on that or not. But this is what the feature looks like, right? So you can specify an angle reference now. Or a mate connector. I don't love the mate connector, actually. So I'm just going to do entity type dot vertex. And do I want that to be an actual vertex? Because vertex allows a lot of things, like I could require it to be like modifiable or something, but it just needs to be a 3D point. It really doesn't matter where. So if you want to select like a model corner, like that's fine. You could orient towards that. So I'm not going to worry about that. And then the line, you just have a direction, so that makes sense. Okay, cool. So let's do some processing of that now. So I'll start with the angle reference. So first we want to know if it's a vertex or a point, right? Angle reference. Okay, so first, if it's not empty, right? So if there is something, then we know, because if there's nothing, then there's nothing to do here, right? We can just move on with our lives. But if there is something here, we need to do something. And so here, let's do is point equals is query empty. Right, and so here I'm going to use QEntityFilter, entity type dot vertex, because that's the same filter as above, right? So this will filter out everything that isn't a vertex, right? So if this query is not empty, then we know it is a point, right? So again, after filtering out everything that's not a vertex, right? So, if the query is for a vertex, right, then our query will not be empty, so therefore it is a point. It's a little confusing, but basically whatever query you have in here, if you have this exclamation mark is query empty, this will check that it is of that type. And then we can also do is line equals is query empty, angle reference, Q entity filter. Oh, that's actually Q geometry filter. Geometry type dot line. Yep. Okay. Yeah. So let's see. So if it is a vertex, right? And technically you don't even need this because you could just assume, but I'll just be safe for now. Else if is line, right? Else throw region error, right? Angle reference, right, and then whatever they selected. Right, and this is definitely very much an edge case. There is actually another fun edge case, which is max number of picks does not actually guarantee there's only one query here. A fun example of how that could be circumvented is if you select like a face, and then you split that face. The query will actually split in two, so you will have two different entities in there. But you know, even if max number of picks is one, it will split that. So there are fun cases like that. And technically, I guess I'll handle it. And the way I'll handle that is using qnth element. So I'll just ignore any extra ones that are in there. Yeah. And then this handles, like, it might be possible to cheat something that's not a vertex or line in there doing shenanigans as well. Although that I'm admittedly less worried about. But I don't know. It wasn't hard to write, so I just did it. It's too late now. It's done. So, but maybe a little unnecessary. You never know. Okay. So let's see here now. So is vertex is line? Yep. So if it's a vertex, I'm going to want to get the point. So we can use evaluate vertex point for that. And then we can use ankle ref, right? Pretty straightforward, right? And then we're going to want to project that point onto our plane. So this is where we're getting a little ahead of ourselves here. I'll also grab the direction if it's here. Evaluate axis, yes, is what you can use here, right? So because we're trying to go from queries to geometry now, right, these are going to be evaluate functions we're looking for. If you're trying to find the one you can use, you can just scroll down to the evaluate section of the documentation, just look through the list, and you should be able to find, you know, which ones are appropriate here pretty easily. Spelling. Okay, so we get our point or direction. I realize I'm putting the cart ahead of the horse a little bit. We do need to figure out what our plane is first, right? So we'll go ahead and do that. So we have our circle, and so our plane is going to be our circle.chord system, right? And then we're going to grab our, and then I'm going to convert that to a plane, right? This is, again, just using my the arrow syntax, right? And all the arrow syntax does is it puts whatever is on the left in as the first argument to the function on the right. So this is equivalent to this, right? And so for like things like query chaining, for example, right? QEntity filter, you see it takes a query to filter and then a entity type to filter on, right? So when you use the arrow syntax, you're effectively running the query immediately. So it's very good for like queries particularly. My other favorite example is you have like start query and then you do like Q subtraction, right? And like other query, right? So if you do syntax like this, Q subtraction takes query 1 and query 2 and subtracts everything in query 2 from query 1, right? So it's kind of like start query minus everything in other query, right? And so when you put it in this form, it's pretty, it's hopefully easier to understand. Like you're starting with start query and you're removing everything in other query from start query. So it's like start query minus other query, is like the set operation. And so like this is particularly readable in my mind, you know, especially compared to like, I mean, otherwise the alternative is this, and you know, that's a little less, or that, you know, is less syntactically evocative, perhaps. Yeah. Okay. Yeah. So there's our plane. And so then, yeah, we'll assume that, and then we'll do plane.normal equals plane.normal times, we'll do plane.normal times equal definition dot flip primary question mark. If that's true, we will flip it, otherwise we won't, right? So we'll make that a var so we can update it. Usually I just default to making everything const, because most of the time you're not actually manipulating things after you've declared it. But every once in a while you do need to adjust it. So here we'll adjust the plane. So this is just using a ternary operator, right? This is equivalent to if definition dot flip primary. You know, then you do plane dot normal times equals -1, right? Otherwise you multiply by 1. So this is just a little bit more concise, right? But yeah, so we flip that, and then we also have to do our secondary axis type. So for that, I'm going to go back to the transform feature, because I believe there's a function in here. Adjust angle? Oh, okay. That's fine. Wasn't this function made... It's always going to do that. I like that function. That just clamps it to a range. It doesn't actually matter, but that does rotation. Where's our type? Okay, yeah. So here's the logic for it, right? They just cross the x and z axes, basically, depending on the value of it. And there's some other logic in here to handle it, but basically we're just getting a new x-axis. And here's the flip for the z-axis as well. So we'll just do that as well. Just copy-paste job again. And they're using the coordinate system, so I guess I'll do that as well, right? I'll just adapt to their code a little bit. So we'll do const, or I guess it's var x-axis equals circle.chord system.x-axis, right? And then var z-axis equals circle.chord system.z-axis times definition.flip primary question mark -1, right? Okay, right, and then we'll just make our plane equals plane, and I'll use the plane constructor, which will take a normal. So that will be our, let's do this, const chord system equals circle.chord system, right? So then we'll just do our chord system dot origin, right? And then what are the other arguments to plane? I believe it's probably normal if I had to guess next, because that's the most important. So this will be z-axis and then x-axis, right? Cool. And then if we debug this, right? I'm just putting in a plane because that's the type new sketch on plane takes a plane, right? So it kind of makes sense to convert. Plus chord system is already taken, so. Although you could also, you know, that's just me being a little facetious, but hopefully you get the idea. Yeah, so we'll debug that and we'll see what we got. So if we do this, right, and then you can see I can give it a flip, right, and I can also give it a rotate. So that does what we want. So we're very happy with that. The other thing to do is the angle, right? So we'll do const angle equals definition dot angle times definition dot opposite direction, question mark -1, question colon 1, right? So exact same thing again, where we take our angle reference, or I guess it's rotation. I'm going to rename it to angle. Angle. Yeah, that seems fine. Yeah, you take your angle and then you multiply it, and then we will simply apply our transformation, right? And so here I know you can do rotation around. So this makes a transform, right? So this is where you get into some fun units, basically. So I need a line, which I can construct from a plane directly, actually. And then, can I? Pretty sure I could. Is there not an overload? I guess there's not. So I know, okay, so the first thing I want is rotation around, right? And like if you just like Control F rotation in here, right, and like click through, you know, you'll pretty quickly find this function, right? So we see it takes a line and an angle, right? It's rotation around the given line, so we know we need a line, right? So if I click line, I can see there's a constructor and it takes an origin and a direction, right? So I think back to like my plane. I know my plane does have an origin and a direction, right? So that probably makes sense, right? So we can pass that in, and then it takes an angle as well, right? And so it does return a transform, right? So transforms are, again, that mathematical concept we were talking about earlier of, so if you look at it, right, it's a change of position orientation 3D space. So it's really just a 4x4 matrix consisting of like, you know, math unit. But basically the benefit, if we read the documentation a little bit, right, so we can see we can compose them by like multiplying them together, right? So it's like transform 2 times transform 1 is equal to applying transform 1 followed by transform 2. And then we can also see we can like transform things using them. And so typically the way you do that is you just multiply. So I bet we could apply that by doing like plane times transform, if I'm not mistaken. I think you can just do that. Nope, I cannot. It says I won't. Let's try the other way around. Aha, yeah. So, and then if I debug my plane again, right, so I saw there my error was cannot apply it, so I just flipped the order of operations. And so now if I enter an angle ref, right, so we can see it does in fact rotate, which is cool. And I can also give it a flip and flip the angle as well. So quite a bit of control there, actually. And then, yeah, and then we just want to do our angle reference now, right? And angle reference would probably apply before the angle, right? So we put the cart a little bit ahead of the horse as well, right? But yeah, so here's our plane, here's our angle ref, right? So now we'll do this, right? So if we have a point, the first thing we're going to want to do is project that point. Project. And then project works in all sorts of things. I know in this case there is an overload that supports planes, right? You can project lines onto planes, you can project points onto lines, and most importantly for us, you can project points onto planes as well. So we'll project that. Actually, I'll just do it like this. No, I can't. Okay. Yeah, so I'll project it. And then we want to verify the error case for this, right, is if the point is the center of our vertex, right, there is no angle reference because, you know, it's like, I mean, they're the same point, right? There's no angle there, which is not good. So the way we will handle that is we will check for it, right? So here, so you might be tempted to do something like this, right? Equals plane dot origin, right? You know, then throw your error, right? The selected angle reference is coincident with the bearing hole. Cannot be. Okay, right, and then so our parameters, right, this is a problem with our bearing edge and our angle reference parameters, right? In the query to highlight here, I'll do a Q union, and I'll highlight both the bearing edge and the angle reference, or angle ref in this case, right? Yeah, so you might be tempted to do an equals equals like this as your guard against your error here. That is actually not what we want to do. And the reason why is because of finite precision. So numbers in Onshape are floats, so they have floating point precision. And so basically, it's possible to represent the same number using, but they're like actually like 0.00000 different, right? And so the only thing that's like guaranteed to be accurate are integers, right? So like 0, 1, 2, 3, 4, 5, like whole numbers, right? Those you can use equals equals on because those representations are precise because it's just how many of them you have or don't have or whatever. But with floating numbers, it's a lot more vague. And so, yeah, so basically like you can't compare them directly, right? So instead you have to account for a little bit of tolerance. And so the way to do that is these tolerant equals functions. And they're overloaded for all sorts of types. So you can like tolerant equal like planes and transforms and all of that. But the like the origin and like the point ones are the most common in like value with units. So I'll go ahead and throw that on there, right? And so, semantically, right, if we look at the code, all it's doing is just using a little tolerance when comparing, right? So yeah, there's just, I mean, that's for the transforms, right? But you can see like, if this difference between them is less than, some small amount squared, then it's fine. So yeah. Anyway, okay, so that's how that works. So, yep, and then we want to actually apply it now. So the way to do that is to probably the easiest thing to do is set the plane.x to point towards the projected point. And so we can make a vector minus plane.origin. I think this needs to be normalized as well. Let's just normalize it like this so it's not unhinged. Right. And this needs to be var as well then. Right. So we can go check that. So we got here. Okay, we'll turn off the angle reference because we don't want them stacking. Yeah, so all we're doing is pointing the x property. So plane is defined by an origin, a normal, and an x. So this is just like basic, well, maybe not basic, but this is like multivariable calculus, right, where they talk about planes and things. So if you set the x direction of the plane, right, so the point in the normal, we want the point to be the center of the hole, of course, and we want the normal to be the direction. It's just like what makes the most geometrical sense. So then it makes sense if you just set the x direction, then like, you will point at that angle reference, right? If they want like 90 degrees from that, they can do that using not that, because the angle reference does have to come first. But, you can logically orient it like that. And so our flip wasn't applying there because we're there's no point in rotating it if you've already set it, which makes sense. So I'm going to copy paste this down here. And so there is kind of a specific order that you have to apply the transforms in, which is fun. And these work on the plane. So let's just do this. For our plane equals plane circle dot chord system. Right, so we'll switch to a plane right here. Right. And then we will, we won't have this. I'll do my plane.x, and then I'll do my plane.normal. Right, and those are just the exact equivalents for coordinate systems versus x-axis. I won't rename that because I'm lazy. And then this will just be plane.origin. And here, okay, so this is fun. I've been avoiding it so far because I'm been lucky, but this is going to be a problem. There's this concept of shadowing, right? So what happens if I create a variable that's the same name as a function, right? So for example, if I name a variable named, 2 times inch, right? So if I name a variable named evaluate curve definition, it's the same name as the function, right? So basically what happens is the function definition is fine until you overwrite it, right? So this is kind of like implicitly overwriting it. It's not actually overwriting it, but it is like inside this scope. So like this function specifically. Once you set it, you shadow the overlying feature definition, right? So if I try like calling evaluate curve definition here now, right? You can see I have a variable and a function now defined, right? Because I've, there's a function from the Onshape standard library, and then there's also my variable definition. And so what happens basically is the variable definition takes precedence over the function declaration. And so I can't, basically this call is no longer valid. So is that right? Should be right. Let's see here. Yeah, and the fun thing is if it does happen, right, like, we can see like Onshape is handling it reasonably well right now, right? But if I come down here, it's going to say call value must be function values value with units map, right? And so that's here, right, because it's trying to call, because the variable has overwritten the function, right? You are essentially doing, like if this was just like my var, right? You're essentially trying to call my var like a function, right? And we can see here my var is very clearly not a function. It's 2 times inches, right? And so this is obviously an invalid call, right? And so that's what this is saying, right? If you're going to call it, it has to be a function because that's the only thing you can call. You can't call, a value with units or whatever value. But the thing is, this error doesn't make it exactly clear like what's happening, right? Because you're like, like what? Like value with units? I'm not trying to call value with units. I'm trying to call a function. What's happening? It's because you've overwritten it. And so like here, for example, right? Originally I had this variable named plane, right? Which is the same name as the function. But it doesn't matter as long as it's coming after, right? Because I wasn't using the plane constructor anymore, so I didn't need it. So it doesn't matter if it's shadowed. But since it is being used again down here, it's already in use. So I'm just going to have to rename this to something else. So I'm not overwriting it. So I still have access to that function. So yeah, a fun little bit of programming lore. It's always a fun issue to encounter. Yeah. Okay, so we'll do that, and then this will be our circle plane, and then we'll keep on chugging. So we'll just overwrite it there, and then this will be our circle plane again, and again, and again, and I'll just overwrite it again, right? Cool, and then now we can make sure our result is completely correct, right? Okay, so I can set my angle reference, right? It'll point towards whatever point I specify, right? Even if my point is not on my point, it'll work. And then if I select my hole, right, I get an error. You can see the error handling we did, right? So we can see the vertex and the edge are both highlighted in red in the query, and then we have our error message, right? And we can see both parameters are red because they both contribute to the error. Although realistically, the angle reference is probably the more problematic point of the two, but it is them working together. So I think it kind of makes sense to highlight them both. But yeah, so there's that. And then let's verify that this all works correctly. So if this is like this, right, it's angled. I can still flip it. Yep, and I can spin it around like that. And I can also enter an angle reference. And I can still spin it around, and I can flip it, and I can flip my angle reference too. Perfect. So we're very happy with that. Yeah, and then we'll also do the line version as well. So this one gives us a direction. So then we'll do the same thing. And our direction is already a plane, so we can just do circle plane equals direction. And the only thing we have to check here is we need our direction to be... if the direction is not in our plane, we have a problem, right? So I'll probably, you could try projecting it. It's kind of annoying though. There's not really a great way to do it because project doesn't work with unitless direct vectors. So instead what I'm probably going to do is, I'm probably just going to require that it's in the circle. So I think we can use evaluate intersection. Yeah, so you can do a line plane intersection. No. Is parallel? Yeah, so we can check if they're parallel. Few parallel planes. Those are queries. Perpendicular vectors. It's technically only a problem if they aren't yeah, so, okay, yeah, perpendicular vectors is what we want here. That's right. So what we can do is we can verify that our direction vector is perpendicular to our circle plane dot normal, right? So 90 degrees to each other. So the direction of the hole has to be perpendicular to the direction you've selected. And if that's not the case, then we can throw our region error again. So we'll copy paste that, and we'll say the selected angle reference must be perpendicular to the bearing hole. Okay, cool. So here, right, if I select an angle reference like this, okay, it wants a line. Yeah, that's right. So here, it needs to be a line, so I'll just do this. Because right now it's just a unitless vector. So it's just like an arbitrary direction. So to give it a direction, I will construct it into a line. Or wait, no, I need a vector. Can I just multiply by meter then? Is that right? No, multiply by meter is wrong. I think I do. Wait. Oh, yeah, sorry. I have to do circle plane. Okay. So I have to make it a vector, so I have to do this. Times meter is just arbitrary. Meter is 1 in Onshape because like lengths are universal. So this is a fun little bit of vector math, right? Do that just to make it clearer. Okay. So if we debug our right? So basically, the problem is a vector doesn't have or a direction doesn't have an origin, right? And so, what? Oh, this is a line. Wait, it's a line? Oh, okay, I think I wanted extract direction. Yeah, okay, and then, oh, this does give a, okay, that's interesting. Angle ref, okay, so that does give a vector actually, so I don't actually have to do that. I was thinking I had a 3D direction, which is not what I want at all, but I don't, I have a vector, so we're okay. So I got confused by my units there. And I was using value axis, which would give me like a physical line in space, so like an origin and the line, which is handy, but not really what I need right now. Yeah, so if I set my angle reference, right, it's just giving me, you know, that vector, and because it's a vector, yeah, as long as it's perpendicular, it's fine. So if we do something like this, it's not perpendicular and we have a problem, and it'll complain, which is good. So yeah, must be perpendicular to the bullet. Must be perpendicular. I guess it must be parallel technically from the user's perspective, right? Because it should be, you know, parallel to the plane. Yeah. Okay, ta-da. Great. So, yep, so I can do my angle reference like that. Oh, that's the bearing edge. Yeah, so I can change this, and I can also like set it like, I guess it just is facing that way like that. And I can flip it, and that all works. So if it was like this, and I select that, oh, I guess it's the same. Wait, really? Oh, okay. Yeah, so this works, basically. Yeah, it's the default, and that's the same. Okay. Cool. All right, so we're very happy with that. So that's our coordinate system figured out. So we like that. Yeah, so now we have our circle plane. So now we have to actually cut some bearing holes, right? So this is where the code we wrote yesterday comes in handy again, right? So I'm gonna copy paste that. Right, we just have one plane to operate on today, because we made that decision. I'll comment that. I'll call these my tools. Just so that way I can query everything really easily. Circle plane, right, sketch same, and then we need our mounting hole radius code again. Okay, we'll just do this, do that, yep. Okay, I'm not going to make the center hole because we're assuming the user has already cut that for us. And then, yeah, so by carefully manipulating our plane, right, we've saved ourselves from having to do a bunch of math, because you can see like we've been manipulating a plane that was always centered in that coordinate system, right? And so like that x direction is always the way we want it. So we can just draw our vectors relative to that. And so that makes it nice and easy. So we can just do this literally. And so if we look at this now, right, we can see there's our sketches, right? Our bearing hole is way too big. That's fine. And then we can go ahead and grab our bounding box length. And here I can use the scope. Although there is, yeah, it's okay because the edge is guaranteed to be part of the bounding box, but there's a fun edge case where if you're doing like the whole feature and you're doing the bounding box thing and you're just doing it around the merge scope, if the hole is not on the part, so it's, you know, off a little ways, your bounding box could be too small. So you would need to make sure your points are also included in your bounding box calculation. But here it doesn't matter because the bearing edge is a part of it. Although maybe I will, just for safety, just throw it in. No, I don't think that's necessary. Yeah, because it shouldn't be, it just isn't possible, so it doesn't matter. Okay, so we'll do that, and then I will extrude, right? Tool ID, extrude. Everything's done by that. By default, the normal should be facing outwards, so we'll extrude the negative way. And we won't have a start depth because I want this to be a direction. We should have a direction now that we're specifying. And then we'll go ahead and Boolean. And so for this, right, and then we also have our cleanup as well. Right, so we can just copy paste that all from yesterday. And then I don't think I need any of this stuff anymore. Yeah, it's just the whole ID and the unstable is really the only thing. So just like doing it in a loop as opposed to once. And the fun thing about doing this in a loop is a little more complicated because we have like these transforms. And like in particular, you would have to apply this guy per point, which is entertaining. Because, you know, different points, they have different angle references mean different things to different ones. So that's the only trick with putting this in a loop. So I'm thankful I don't have to do that. Well, it wouldn't be too bad to do, but, you know, it's annoying. So, okay. Ta-da! And then, yeah, so our sketch was too big, right? So if I make this, like, actually a reasonable size bearing hole, still no. Interesting. Okay. Oh yeah, definition.scope. But you know, if we're having an issue with cannot resolve entities, right? The easiest thing to do is to start debugging your inputs, right? So you know, there it was definition.scope, right? You debug that, you see undefined in your console, you realize like, oh, there is no definition.scope. I wonder why that is, right? You look up here, you realize there's no scope parameter, and you realize that's because you're getting the scope somewhere else. So definition.scope is wrong. And then, you know, if there is something there and it looks correct, then you debug the tools and make sure that's correct as well. And then if everything's right, then you write an Onshape support ticket. No, don't do that. But I don't know, then you think a little bit harder about your life, I guess. But like usually, you know, there will be something wrong with your input usually, in some way. If you debug both and like they both look right, then maybe then I would try to do like a simplified example, or, you know, like verify that, you know, the feature works the way you expect it to, with like a trivial example, you know, like I'm just going to like, you know, remove like a simple box from like everything, right? Make sure that works. If that works, then, you know, you can kind of work your way up, you know, basic programming, debugging, or you can just be like me and just spot the problem immediately. Maybe don't bank on that. Okay, so we've extruded, and we've booleaned. Okay, cool. So I have the direction the wrong way. And I'm surprised the boolean feature isn't actually failing. That is very interesting. Okay, so I'm going to do something a little bit fancy here. I'm going to use a special feature. What is this? Process foreign data info? What? What is that? Foreign? Okay. Huh. Not sure what that's about. Okay, so I'm going to use this fancy function called process new body if needed, right? So what this is dot remove, right? And then my Boolean scope is my scope, And I do not have a default scope on this guy, so I won't do that. So what this feature does is, actually I could do that. No, I won't, because we're getting the scope. Yeah, so I don't need that. So this is for adding a Boolean step to features, right? And so you might say, well, what's a Boolean step, right? And so that's simply the idea that a feature will do something, create something, right? And then you will have the option to Boolean it to something afterwards, right? So extrude, for example, right? You can just do a new extrude, but you can also Boolean it onto something, Boolean subtract, Boolean intersect after, right? Revolve has a Boolean step, right? You can add, remove, intersect, right? Other features, mirror has a Boolean step, add, remove, intersect, right? Pattern has a Boolean step, and you add, remove, intersect, right? So it's just that set of options, right? And so anytime you have a Boolean step, you have to have your new add, remove, intersect, and then you also have your merge scope, right, as a part of that. And so that pattern is so common, right, that it's actually defined in 2 parameters. So there's a Boolean step type predicate in the Onshape standard library that you just have to export the correct import, which is defined. The documentation tells you what to do. If you look at it, yeah, you need this import. You just specify whatever version you have, right? It is just toolfs. Okay. Yeah, so you can you add the Boolean step type predicate, which is the new add remove Boolean, and then you add the Boolean step scope, which is the default scope, and then that's your merge with all, and then merge scope parameters, and then there's also, and then the last part is this process new body if needed, which interfaces with those above mentioned parameters and does the actual Boolean. And the way it works is it just grabs everything that was created by this ID and then Booleans it with whatever your scope is. And then the cool thing, right, so it gives you this warning, which is actually a little bit wrong. Well, actually, I guess this is technically a little bit wrong. Because like a Boolean remove, for example, is very forgiving actually. If you don't have it, like, you get the warning, you get the error highlighting, right? But it's not actually an error. Like, this is an okay feature, even though it's not doing anything, which I don't like, because a robot bearing hat feature that's not cutting any coals should be an error. So instead, I guess I'll just roll my own. Targets. Yeah, so what I'm going to do is I'm going to wrap this in a try catch. I'm not going to worry about the error. Does this really not? Feature's not creating anything. What the? Really? Yeah, it's doing that. There's no Boolean. I thought the Boolean would fail in this case. I really did. What is process new body? Okay, let's go look at the source code. I'm surprised my Boolean is not throwing an error in that case. Oh, maybe it's throwing like a read-only info status or something. This might be a call subfeature in process status moment. Oh, I guess we could also do a process feature status. Oh yeah, so this, okay, yep, it's coming back to me. Okay, so basically, so in a case like this, what's happening, right, is our Boolean is failing but it's not an error per se. It's just a warning, right? And so by default, that doesn't actually get propagated up the tree, right? It just gets tied to this identity, but because this identity is not the feature ID, it doesn't fail. And so actually, we could see the error directly if we get rid of that and pass in the top level ID, right? So this is that selected tools and targets do not intersect, right? That actually comes from the OP Boolean itself, but it just gets hidden because when you give it a sub ID, info statuses like that do not propagate up the tree by default, and so it just doesn't get shown, right? So the feature is just happy completely, right? So you could just do it like that, right, and just give it the top level ID, but you can only do that once because each ID can only be used once. So generally, you don't really want to do that unless you're like actually wrapping around OP Boolean like completely. So instead, what we can do is we can use a function called process subfeature status, and what this does is it will roll up those other statuses, right? So if we just do this, right? Once it loads, okay, Onshape is struggling right now. Oh, Onshape is really struggling. Or my internet is down. I hope that's not the case. That would be unfortunate. Give it a refresh. Okay, it's struggling. Struggle again. Okay. Hello? Okay. Onshape is not having a good time. But basically that status should propagate, right? Okay, I guess I'll keep coding while that loads. And then the other part of it is we can actually propagate that error as well, or we can escalate that error. So process sub feature status. Yeah, so we can override the status, right? Which I am going to do. Oh, that's for, oh, boo. Okay, that's for an actual error message. For warning your error, yeah. I can propagate the error display. I can also add additional. I don't love that. Is there an error display to propagate? True. Curious now, actually. Let's see. I think there is error display, which is fun. Onshape's not having a good time. Is process sub feature status correct here? I guess it's not. I really want an error. What does whole do? That's a good question. Oh, that's cool. Oh, it only supports array parameters. Boo! Wait, that's actually sick though. Why does it only support array elements? Use button. Also, where is this? This is in utilities? Okay. For tracking. Whole definition. Instantiator, yeah. Manipulators. Okay, we're back. Yay. Alright, yeah, so we can see the error display propagating, and then, but there is no actual error display. Some features will, like, actually highlight the bodies for you. Boolean does not, which is a little sad. Image data, yeah. Cat import data. Okay, I'm just scrolling through the standard libraries. This has been a while since I've done this, and it's always fun seeing the new things that they've added. Like the ability to programmatically hide features, it's pretty neat, or hide parameters at runtime. Yeah. Although, I'm trying to imagine cases where that would be actually helpful. Oh, I guess you could set whatever conditions you want. Oh, that actually would be really useful. It's too bad it only works with array parameters. It's kind of goofy. Okay, anyway, yeah, there's all the Onshape features, cut list. Okay, anyway, I wonder if they've added any new UI hints. Display short, show label. Always use dependencies, what? Whether they specify is positive or negative. Can be tolerant, focus on visible. Oh, that's handy. Okay, anyway, humdy-dum-de-dum, display current value only. Okay, yeah. Alright, so, yeah, alright, let's see what whole does for error handling, I suppose. That is, nope. Did they release another version? They did, today, wow. Fascinating. Okay, so, is it? Okay. Did they finally fix their search? Oh, it looks like they did. That's so nice. Okay. Yeah. For the longest time, Onshape would, the search would just be it would just, like, count the total, and it wouldn't, like, filter. So, like, oh, I guess not really. Okay. Yeah, this is still not great. Come on, Onshape. Like, I mean, you type it in exactly and it doesn't propagate to the top. Like, it's not great. It's not ideal. Not what you want. Okay, so let's see here. So there is an OP hole in here. I assume there is. I don't actually know. OP hole, create hole attributes. Yeah. Okay. I think I'm just gonna have to roll it myself. So what can I do? Surely they're not getting the feature status though, right? Reporting status? Result.errors. Okay, interesting. Let's see here. Cut hole result error, and it also does warnings. That's neat. Okay, so they have a bunch of error handling there. Doesn't OP hole do stuff like this? Which failed to build. If no tools can be built, the operation will fail. Yeah, but there's a bunch of stuff in here that we don't need, like depth and whatnot. Success false. So OP hole I know does have fairly good error handling. Otherwise, I mean, it might just be process subfeature status. Oh wait, process new body if needed, sorry. Operation type. So it'll be excluded from the target section of the Boolean. Okay, it might just have to be process new body if needed. Yeah. I don't know. I know I could use like get feature status, but I'm hesitant to do that because I've never actually had to do that before. And so that just feels wrong to me. But maybe that's correct here. I'm not actually sure. Okay, no, I don't want a default scope. I don't want a scope. Let's just try it, I guess. So the way this works, right. So this is definitely quite fancy. Basically, the idea is sometimes if the Boolean itself fails, right? So for example, if you go to Boolean and the tool is creating like a like perfectly aligns with like the edge of the geometry, or something like that, where like the part it's trying to produce is like completely invalid inside Onshape, right? Or like in Parasolid, right? So in that case, like the Boolean isn't gonna say like they don't intersect, right? Like the Boolean itself is going to fail because it cannot like do that Boolean. Like the result is completely invalid within Onshape, and so in that case, right, you're going to lose your target. You're going to lose your tools. You're going to lose your targets. Now you could. And like even if you set like keep tools to true, like that's not going to work necessarily, because the Boolean itself is like completely failed, right? Like it's crashed out basically. And so the idea is in cases like that, you still want to show something to the user so they know what's happening, right? So what you do is you actually generate the tools again. And then you don't Boolean this time, and you say like, hey, FYI, like I tried Booleaning with these tools and it didn't work. You should fix it, right? And so that's what this reconstruct op is, right? So if the Boolean completely crashes out, or in just like a regular error case where like it's not intersecting, it's going to run that function and display whatever it produces to the user. And so I think, let's see here. Do I need more than the extrude? I don't think so. Yeah, because it'll lose the extrude. No, I think it'll lose the sketch as well. Wait, what does it lose? Yeah, I'm going to assume the feature, yeah, so everything that was getting made is lost, so it's also going to lose the sketch. But like the variables will be okay, so like the length and whatnot. So I'm going to paste this in here as well, right? Obviously this is very, like anytime you're copying and pasting code as a developer, it never feels good. But I'm trying to avoid factoring this out for now, just because I want to get it done quick and dirty, and then we can go back and clean it up and add functions and whatnot later. Yeah, so we'll do this. ID, that's the top level ID. Yep. So theoretically now with this, right, let's see here. Nope, you're not happy. Why aren't you happy? Is that error entities? Remove error ID, error ID, error ID. OP extrude. Throw feature no solids. That's objectively not true. Oh, it's saying it's not finding the solid extrudes. That's weird. Oh, I left my boolean in. Yeah, don't want that. Okay. So this is in lieu of the boolean, right? I'll keep it around just for posterity, just for old time's sake. But yeah, so ta-da, right? So here, process new body is being run, and we're not getting. Do I actually need these then? Hold on, let me slash these out here, and we'll use tool ID. Okay, we don't need those. Yep. Is that right? I guess so, yeah. There's no reason why those should fail. Yeah, because they're not involved in the extrude. Or they're not part of the tools, so I just need to recreate the tools. Yep. So we can see our reconstruct op gets run. Let me verify that. Sometimes you don't actually need that even. Oh, you do need that. Interesting, interesting, interesting. Okay. Yep. So our extrude is being run, and this is going ahead and capturing that basically. So we can see we're getting our error now, which we're happy about. And I do want to escalate the warning to an error. Could I just... I guess I could just do it myself as well. Let me try this, I guess. True. And then I'll throw a region error. That's technically wrong. No, it's okay. It doesn't, it's not unhappy about that. So, okay. How am I doing in my other features? This is what I get for not programming in a while. I know Pulley has good error handling. Let's go take a look at that. That's flanges. Okay, so I'm just doing it like that. Yeah. Interesting. Okay. Yeah, so this works because, I mean, the bore is guaranteed to intersect the pulley because I'm creating the bore and the pulley in the same part. So there's no need to handle that. I could not crash out the feature. I don't have to do that necessarily. Otherwise, I just like check the feature status, right? Non-trivial status, ID plus boolean. Okay, I'm gonna use the no error. Or is there like a generic error? That was regen error. Okay, nice. So I'll throw a regen error and then I'll immediately catch it, just so I only have to do my error in one place. So this way, if the boolean itself fails or it has some non-trivial status, right, we can assume something went wrong. So here, I am going to extrude it again, right? And here I'm going to error ID equals ID plus error, right? So I'm going to extrude my geometry again. I am going to, and then I'm going to, and then I'm going to do circle bearing edge again. And then I'm going to, here I'm going to query for this error ID, right? And so this way I'm guaranteed to have an extrude I can highlight for the user. And so that produces this output. Yeah, so ta-da! We're happy with that. And maybe, I'm wondering if it would be better to roll up the extrude status into a warning. And then, what are the options again? It's also very late. I don't know. This is definitely just me getting a little lost in error handling as well. Subfeature error display, additional error display, entities, feature parameter map. Yeah, because that's, wait, is that error string enum? Wait, hold on. Am I just silly? No, that's, yeah, error string enum is like a string, so that would be a different, that's if you wanted to swap out the message. I don't know. Are there any examples in the standard library of I mean, this checks it. Oh, they actually delete them. Interesting. Why do they delete them? Does it change the error display at all? Oh, I guess if they're not crashing the feature, then they won't get rolled back, so you do have to clean them up. Interesting, interesting, interesting. Yeah. Joinable surface edge, filter overlapping edges. Okay. Yeah, it's really not used very often. Sheet metal done. Okay, that makes me think. Okay, we'll do it like this, I think. Okay, so we'll just throw an error like that, right? Yeah, so when you have an error now, right, if the tools and targets don't intersect, which is a pretty common error if I had to guess, then you'll get an error and you'll have a nice error display. Cool, so we're very happy with that. And then the last thing to do would be, yeah, so this is a pretty functional feature, right? I mean, it cuts it. You can do all your angle reference shenanigans that you'd possibly want. Everything you could, hope and dream of, presumably, right? So we're pretty happy with that. So then the only other thing, yeah, you could do your fit. I don't love that. We'll just make it a whole fit. Yeah. And then you can do your fit as well, which is nice. So the only other thing is there's a couple different bearing sizes I want to add, and then if I was even fancier, I could also show the hat as well. That's probably a little overkill though. But yeah, so I want to add a version where you can actually create the actual hat, or like create like a 3D printed version of the hat if you're not like buying one, like a metal version, or making one yourself. And then there's some different hat designs I want to cover as well. And then the other main thing I need to do is I need to do manipulators. So generally there's like there should be like probably like a direction flip manipulator, and then like an angle manipulator for your angle. So those would both be probably good to include, if not a touch overkill. But I like to include those frills in my features. I think they are helpful. Yeah, so I'll probably be working on that next time. So I'm gonna end this here and go to bed. But hopefully this was helpful. And it wasn't just me staring at the documentation and source code trying to figure out how to do error handling and whatnot. I know we got a little lost there. But you can kind of see how I like to go about developing features, and how you can leverage the documentation and leverage the Onshape standard library to help you write features, and work with all the various units and things. Cool. So I'll end it here, and I'll talk to you guys later.